All right. So for this particular setup, which is for Ubuntu, we are going to use OpenSSL. So we need Bash. And for Bash, I'm going to be using the Ubuntu machine. We are going to go to the terminal. And then inside the terminal, first we will check whether OpenSSL is installed. OpenSSL -h, and it looks like this is an invalid command. All right. So if I just do OpenSSL, it is working actually. So it is a good thing. All right. Okay, so let me do Control C. We are going to first generate. So we'll first generate an ECC pair using the SECP 256K1 curve. All right. This is the curve that is also used with Bitcoin. So for that, we are going to do OpenSSL EC param gen key name and SECPK 256K1 and no out and out would be the private SECP 256K 256K1 dot pem. All right, this will generate my private key and save it to the name private SECP 256K1 dot pem file. Similarly, I will create a public key. So for this, I will use open SSL EC input private SECP 256K1 dot pem pub out public dot SECP 256K1 dot pem. All right, and we should have now, if I do ls, I should have my private and my public key both available to me. I think I made a mistake with that, so let me just do just fix the name. Should be public hyphen. Sorry about that. Public hyphen. Okay. Sorry about that. So now we have the name which is fixed properly. Now we will generate. We need to actually now measure the performance of the ECC key generation. So we will use time open SSL EC param gen key with the name SECP 256K1 no out private SECP basically the intention is I want to see how long it takes to generate. All right. And if I do that, I should get some information. But this is not a really very good measure. In fact, I can do the same thing for the public key. So I can do time open SSL EC -in private SECP 256K1 dot pem about, and then I will output the public SECP 256K1 dot pem. All right. So I have now these. So for me, both the times are there, but this is not a very good measure. because it is only one-time measurement. Instead, if I want to measure the performance of the ECC key generation multiple times on an average, I may need to create a bash script. And here I may want to measure the performance of the ECC key generation multiple times and take advantage of generating the public and the private key separately. To do that, I will actually write a separate type of bash script and then try to simulate this. Now, for this, running this means that we will create a bash script, and that bash script would allow us to test how quickly or what is the performance, all right, of each of these. So let's go ahead, let's try that. We can actually go ahead and see that we can create a quick bash file. So let me say nano ECC perform. I think there is a name structure. Please follow that. Performance dot sh, which is the bash file that I'm going to be creating. All right, now here I'm going to prepare my file so that I can measure the performance. All right, so for this, I will first go ahead and I will do mm, bin bash. Then I want to create my, I think there are, I need the curves that I want to test. So this will be my curves. These are all the flavors I want to check. So I've said SEC P256K1. And then again, I have the prime 256V1. And then I have the SEC 384 R1. And then I have the brain pool P5512 T1. All right, so these are going to be my curves, which are the ones that I will test. And then I will also compute because I need to compute the average time. I will go ahead and I will use specific commands to be able to do that. So let me do um, so what I'm going to do is I'm going to create two arrays, and I'll create so for curve in curves, do, and here I'm going to do the actual generation that I was doing. So the private time, the one that I just did the time on, I will say private time is equal to, and I will do the actual computation, which is the time open SSL EC param uh, gen key name dollar curve no out, and I will put private underscore dollar. This is the curve dot pem. Okay, and then I will, if there is an error, no problem. I'm going to put it in the dev null slash dev slash null. And if there is even a error beyond that, I will again put it to, I think this is not the right, oh yes, it is correct. Okay, one again. All right, so I will again put it to dev null. So for me, errors don't matter. And I will keep totaling them because I'm going to average them a little later. So I will do um, private underscore time plus is equal to, because I'm going to do this for everything. So private underscore time. Okay. And then I'm going to do the same thing for the public key. All right, so just like I have done it for the private key, I will again do it for the public key. So I will do public underscore time is equal to dollar time open SSL EC, sorry, the same command that we have used previously on the bash shell, and then private underscore dollar curve dot pem pub out public underscore dollar curve dot pem. Okay. And then once again, I will use the dev null formula to slash dev slash null. And I will also go ahead and I will cannot take it. This is public times, right? It cannot be the same. So public times plus is equal to, and then this is the total of the public time, which is what we are trying to. And then I will then go ahead and I will do the compute the average of this. So I will do dollar public time. I forgot the this is public underscore time. Okay, I will close it up here. I think I forgot the dollar on the top. See, little things, a dollar on the top. Okay. And then, of course, I need to find the average. So I will find the average here. And of course, I need to also clean the files. So I'm going to do remove -f all the private underscore dollar curve dot pem and the public underscore dollar curve dot pem. And I will also, sorry about that, dot pem. And then I will compute the average, which is what I want to print. So I will say private underscore avg is equal to dollar compute average, which is what I'm going to do in the next few minutes. All right. So I will make a function called compute average. But the part that is most important is I do need to just divide this by, so compute the average by sharing the details. All right. That's what we are going to be doing. But let me stop here and let me quickly show you how the, so I'm just going to show you how the final program should look like. So the final code should look something similar to this. Here you would actually take out your curves. You will give it in the format that is needed. You will compute the average of all the times. You will also go ahead and use the string function. You will remove all the extra string function related requirements so that it is presentable in the format that is needed for the assignments. And then, of course, this is the actual loop and this is the computation of the private average. But of course, we are outputting it to a file that we need. All right. that should give you enough guidance for your assignments.